Welcome in my channel Digital World. In today's video, we learn about how to use virtual lab platform to design and simulate digital circuits. So today we have to learn about multiplexer. So click here and type it google.com, search for VLab. So click on VLab IIT Bombay. Click on first tab, that is IIT Bombay. There are multiple labs are there, chemical engineering, digital applications. So you click on digital logic design lab. So click on list of experiments. So there are multiple experiments we can perform. Today we have to perform 8:1 mux. So click on implementation of 8:1 multiplexer using MSI ICs. Read aim to design and implement 8:1 mux using IC 74LS153 and verify its truth table. This is theory regarding 8:1 mux, how 8:1 mux work. So there are 4 inputs are there, and with respect to select line we can pass any one input toward the loudspeaker. This is general block diagram of 8:1 mux or N:1 mux. These are the select lines. This is the design of 8:1 mux using 74LS153 IC. This is dual 4:1 mux IC. So first part is 4:1 mux. It consists of 4 input and 1 output. And in the second case, there are 4 inputs and 1 output for second mux. So for 8:1 mux, there are 3 selection line. Pin number 14 is S0, pin number 2 this is S1, and we have to enable first block with respect to pin number 1 and second block with respect to pin number 15. So we are using 3 selection lines A, B and C in. A is connected to S0, B is connected to S1 and C is used as a enable. So whenever C is equal to 0, first 4:1 mux will be enabled, and when C is equal to 1, second 4:1 mux will be selected. So we have to OR outputs with respect to pin number 7 is connected to pin number 1 of OR gate, pin number 9 is connected to pin number 2 of OR gate, and finally output is connected to LED. So this design is 8:1 multiplexer using IC 74LS153. This is internal logic diagram of 8:1 mux. This is the truth table of 8:1 mux. There are 3 selection lines 0, 0, 0. So y is equal to D0. So D0 is equal to 0. It represents y is equal to 0. With same conditions 0, 0, 0. When D0 is equal to 1, y should be 1. In this way, we have to check for all possible conditions till 1, 1, 1. So when selection line is 1, 1, 1, then whatever at last pin, that is of D7, that will be at output. So when D7 is equal to 0, y is 0. When D7 is equal to 1, y is equal to 1. So this is the basic theory of 8:1 mux. So click on Pretest. There are few questions are given. So read those questions and tick the right answer. The next one is how to work with 8:1 mux. So these are the few steps are given. For 8:1 mux, there are total 8 inputs are there, D0 to D7, and it is represented as I means input and P0 is your first input. Similarly, there are 3 selection lines. A, this is LSB, it is connected to pin number 13, B is connected to 14 and C is connected to 15. And for 8:1 mux, there is single output is there, that is P6. Here one small video is there, you can click on this and you can just check that how to simulate 8:1 mux. I will go for simulation. So click on simulation, right? So here inputs are given. So there are total 3 selection lines and there are total 8 inputs are there, D0 to D7. For 8:1 mux, there is single output is there, that is of y, and it is connected to O. O is output and this is P6. Now just go through the diagram. As per theory we had studied, we require one single IC, that is of 74LS153. This is dual 4:1 mux. Then we require OR gate and we require inverter, right? So this is the circuit diagram for 8:1 mux. So this is main switch. To simulate our design, first click on main switch. Next one is there are 8 inputs, IP0 to IP7, and there are 3 selection line. So IP3 is nothing but A, IP4 is nothing but B, and IP15 is nothing but C. And there is single output that is connected to OP6. Now as per the truth table, we have to simulate design. First click on mains. So main switch is on, right? So here VCC LED is on. Now we can check the condition when all select lines are 0, 0, 0, whatever at IP0 that will be at output. Now here IP0 is 0, so OP6 is 0. Now you click on IP0. Now IP0 is equal to 1, then automatically output that P6 will be on condition. Now check the second condition. This is 0, 0, 1. So whenever selection lines are 0, 0, 1, whatever at next input, that will be at output. So here we can say this P1 is equal to 0, then output P6 is equal to 0. Now you click on P1. So when P1 is equal to 1, P6 will be on. In this case, we have to study the rest of the cases. For example, here is 0, 1, 1, this is 3. So whenever the select lines are 3, then you click on IP3 or input P3. Here P3 is equal to 0, so output P6 is equal to 0. Now if you want to show in waveform, then you can just click on capture and then stop this condition. Right, now we can see here select lines are IP15 is 0, so this IP15 is 0, IP14 and 13 both are 1. So here IP14 transition is from 0 to 1, IP13 transition is from 0 to 1, and we can say this is 3. So what are the status of 3? That should be 0. So this is 0. So whenever IP3 is equal to 0, then automatically P6 is equal to 0. Now change the condition, click on P3, so P3 become 1, then automatically P6 becomes 1, so output is equal to 1. Now again you click on capture and stop that condition after some time. So this is stop. We can say IP15 0, IP14 1, IP13 that is 1, and the condition for P3 is equal to 1. So when P3 is equal to 1, P6 is 0, sorry P6 is 1, and when P3 is equal to 0, your P6 is 0. So this is the way that we have to check about 8:1 mux. Now check the last condition. This is 1, 1, 1. In that case, whatever at IP7, that will be at output, no matter what are the other status are. So here P7 is 0, so here we can say P6 is 0. So whenever the P7 is 1, then we can say P6 is 1. So what are the conditions are there? We can say here P3 is equal to 0, then also P6 is equal to 1. So in this way we have to check that how that mux works. So this is the circuit diagram of 8:1 mux. Now the next one is, this is post test. As per our observation, read the questions and write the answers. These are the references for 8:1 mux, and just click on feedback and try to give the feedback. So in this way we have to know that how to use virtual platform to simulate different types of digital circuits. Thank you so much.